we have the second ADCC example working now in callbacks mode with the data streamer. And let's have a look at what happens with the spike detection. So again, here we see that there's a diff of features, and since we have callbacks mode working, it's easier to just keep going with that one and go on. It's not a big difference. You could go to polled. You just have to make sure that you uncheck the interrupts of the different peripherals. Here we are using the timer, but I'll go first to the callbacks version, and then we'll have a look and scale back to the polled version afterwards. Okay, but what does this one do? So here, this is what we were doing before, just a simple plot of our potentiometer. And here we're going to have three different variables, one in ADC result, an ADC result last spike, which represents, well, the spike in this case is going to be a rate of change of the ADC reading, and when we turn our pot quickly, we're going to get lots of spikes, and when we turn very slowly, we're not going to get so many. So we'll show you how to set this up. There's a video there as well, using the API reference, and this video is obviously using the example component. Okay, so we have some settings for the ADCC, and okay. So yes, we have one of the interrupts already. We also want the threshold interrupt, and hardware settings, positive channel. Okay, that's the, now this is different to what we chose in the previous example, because the positive input channel here, here under pin grid view we have an analog input pin on pin 7. Here we're essentially selecting that as well, but as a kind of default pin, so that we can call certain API without having to specify an analog input, because we set the default to what is useful. Okay, then computation. So if I just search in here for computation, you can see all these features, less than and greater than, so less than and greater than, so that's that one. The threshold is -35 and 100. Okay, the timer, so back to the boulder, the timer, and we want this to be 100 milliseconds. Well, that's correct. Yes, so just double checking that one. And timer interrupt, yes. And now our data stream is going to change. So we had a result before, now we have another UN16 of last spike, and we have an ADC spike count, which is a UN date. For all the examples, the pins are all the same. UART. Let's go to the UART. Interrupt driven. Yes, it was there from before. Sometimes it's just about double checking the settings. And notifications. ADC example, yes. The timer. 248 or timer 0 in 8-bit mode. Yes, and we have handled these items before. Note specifically that we have had to check under system config bits to disable this oscillator here, external oscillator selection, due to it being on the same pin as clock in, which we verified from the data sheet here. And this table is still open here, so analog 7 is the clock in, and for the ADCC we can now remove that. We set the clock divider high enough so that we didn't get a time for ADC conversion error, and our UART is not giving us an error notification either. Okay, so that looks like all the settings, and okay, so generating code as before, going into source, examples, ADC example, and our ADC example is already open. So just comparing the code as before. So there's a little bit more here, but you don't see such a big difference between two different callback implementations. But obviously the polled versions are generally quite short. Okay, so we're in timer 0. Best practice, control click just to check that we've got the interface correct. Yeah, analog 7. Okay, and there are 4 interrupts in this project. You can see that there's an ADC interrupt, an ADC threshold interrupt. So the conversion callback, that's the standard conversion complete. So we are starting a conversion on the timer callback every 100 milliseconds. Then when our conversion is done, we get a result, and now and again we will get a spike threshold, in which case we update the spike result. Okay, so let's program, well, build first. And program. So we're expecting this to stop making sense as soon as it's programmed. So there it's programmed, and you can see it's losing things here, and that's expected. But we are getting spikes here on the ADC when we move it quickly, so it's not complete rubbish, but we do need to delete this, import generated files .streamer. You can see we have an extra 2 bytes in our frame. So 115200, yes. Okay, let's just delete some of these plots here quickly. Then we can go plot all variables, and everything is all kind of set up. Okay, now we can add our debug IO. Okay, so everything is now working. So as I move the potentiometer quite slowly, the last ADC sample gets away from the last spike. As I move it very quickly, the 2 plots stay with each other, and we're getting all these spike interrupts all the time, right? It's more difficult for me to move it slowly down because the ADC is set to be more sensitive in the down direction. Yeah. Okay, anyway, the example is working, and yeah, well, in the next one what we'll do is try and step backwards from the callbacks version, which tends to be a bit more configuration, down to the polled version of this. Typically the opposite direction one tends to be going.